Hello, quarantined biologists. Get ready for virtual learning week 3. If you couldn't tell, I've been losing my mind over quarantine a little bit, so I grew myself a friend who has real DNA and proteins, just like you. And that's what we're going to talk about this week. More DNA and more proteins. But specifically, we're going to look at exactly how those proteins are made and what happens if there's a mistake or a mutation in our DNA. If you forgot everything from last week, you can get a recap right here. We're starting this week off by reviewing protein synthesis, which is just a fancy word for making proteins. There's 2 main characters in protein synthesis. One, DNA, who we know a lot about, who resides in the nucleus of the cell, and ribosomes, who live outside the nucleus. If we remember from last week, the DNA has the instructions for making everything, making proteins. And now ribosomes, they're the builder. Can they build it? Yes, they can. And DNA cannot leave the nucleus. Ribosomes can't go into the nucleus. They're like star-crossed lovers destined to be apart for all of eternity. Life is cruel. Life is unfair. So how are we going to get these instructions out to the builders? So here we have some DNA code. This cannot leave the nucleus. Luckily, messenger RNA code can. We abbreviate that as mRNA. So DNA gets changed into an mRNA code. The G's always get changed to C's. The C's always get changed to G's. T's always get changed to A. And U is what A gets changed into. So our new code is CGAU. And now it's ready to get shipped off. Now our messenger RNA is ready to leave the nucleus and go to the ribosomes. 2 ribosomes. I can't leave my nucleus! Somebody come take this to the ribosomes! 2 ribosomes? That's me! Boys, we got more work to do! We got more instructions for proteins! Yeah! So now that these builders have the instructions, or the mRNA, right here, they can read the code, and it tells them what to build. These builders read everything 3 at a time. So they'll read these 3, and give it this tiny little amino acid, and that's what makes up all of our proteins. So every time they read a group of 3 in the mRNA, they give it an amino acid, and another amino acid, and then all these amino acids string together to become our proteins that make up our hair, and our skin, and our food, and our bones, and all the things, as you know. Now sometimes our DNA code can get mutated, or damaged in a certain way, or changed in a certain way.
So what you're saying is that if my DNA mutates, I can turn into the Hulk? Ah! 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 Ah!
Unfortunately, we can't turn into the Hulk, or Wolverine, or Teenage Mutant Ninja Turtles. That'd be pretty cool though. Mutations in our DNA can be good, bad, or neutral. Some mutations can be good. For example, they can change the shape of a bird's beak to make it easier to get food. We call that natural selection, don't we? Some mutations are just neutral. They're not good or bad. Like flower color. Doesn't matter. And some mutations are bad. Like harmful UV rays from the sun can cause damage to our DNA and cause mutations like skin cancer. So, sunscreen up. Just stay cool. So if we have some DNA code that gets mutated, there's a couple options that could happen when it gets mutated. Sometimes a base could get added in, and now we've got another A in there. Sometimes something gets completely deleted, and then we're getting rid of part of the instructions. Sometimes we substitute one letter for another. And sometimes in really bad cases, everything gets messed up and it's unreadable and it's ruined. So, if DNA code is the instructions get messed up, sometimes a different protein gets made, or one doesn't get made at all. So now, hopefully, we know a little bit more about DNA and making proteins, and what happens if our DNA gets mutated. So, good luck with the rest of your work this week, and if you get outside, remember to put some sunscreen on.